Hello everybody. Today's topic of discussion is icocyanoids. Icocyanoids contain 20 carbon, and the icocyanoids are of two types, prostaglandin and leukotrienes. So prostaglandin is a 20 carbon containing carboxylic acid. It contains cyclopentane ring and two double bond between C5 and C6 and between C13 and C14. Then subclassification of prostaglandin. First of all, prostaglandin A. It contains keto group at C9 and double bond between C10 and C11. Then prostaglandin B. It contains keto group at C9 and the double bond between C8 and C12. Then prostaglandin D. It contains hydroxyl group at C9 and keto group on C11. Then prostaglandin E. It comes from ether solubility. It contains hydroxyl group at C11 and keto group in C9. Prostaglandin F. It contains two hydroxyl group at C9 and C11. F comes from phosphate buffer solubility. Then prostaglandin G. It contains hydroperoxyl group at C15 and cyclopentane endoperoxide between C9 and C11. Then prostaglandin H. It contains hydroxyl group at C15 and cyclopentane endoperoxide between C9 and C11. Then prostacyclin. It contains epoxide. Then thromboxane A2. It contains oxygen and it's secreted from thrombocyte, that is platelet. So the name of the compound is thromboxane. Then the leukotrienes. Leukotrienes are leukotrienes A4, B4, C4, D4 and E4. Next, the function of prostaglandin. Prostaglandin D2 and E2 same function. It causes vasodilatation, it causes bronchodilation, and it causes increased vascular permeability. Prostaglandin F2 alpha, it causes vasodilatation, it causes bronchoconstriction, and it is responsible for uterine contraction. Then thromboxane A2, it causes vasoconstriction, bronchoconstriction, and platelet aggregation. And prostaglandin I2, it causes vasodilatation, bronchodilation, and antiplatelet aggregation. So thromboxane A2 and PGI2 has got opposite function, and thromboxane A2 is secreted from platelet, and prostacyclin, that is PGI2, is secreted from endothelium. Then the function of leukotrienes. Leukotrienes B4 has got a function of chemotactic function and cell adhesion function. And leukotrienes C4, D4, E4 are got the same function. It causes vasoconstriction, bronchoconstriction, and it causes increased vascular permeability. Then synthesis of icocyanoids. How the icocyanoids are synthesized? Icocyanoids are synthesized by several steps shown in the figure. First, membrane phospholipid release the arachidonic acid by the action of phospholipase A2. That is, phospholipase A2 breaks the ester linkage. It is attached to the C2 carbon of glycerol and release the fatty acid, that is the arachidonic acid. And this phospholipase A2 is inhibited by the glucocorticoid, and this is the mechanism of action of glucocorticoids. Then phospholipase A2 is stimulated by the epinephrine, angiotensin 2, bradykinin, and vasopressin. Then arachidonic acid is either enters into the cyclooxygenase pathway or lipoxygenase pathway. When it enters into the cyclooxygenase pathway, it synthesizes prostaglandin. When it enters into the lipoxygenase pathway, it synthesizes the leukotrienes. So first of all, when arachidonic acid enters into the cyclooxygenase pathway, it first synthesizes the PGG2 by the COX enzyme, that is the cyclooxygenase, and the COX inhibitors in drugs can inhibit the cyclooxygenase enzyme. Then PGG2 by the action of peroxidase is converted to PGH2. Then PGH2 either converted to PGD2 by the isomerase enzyme or it's converted to PGE2 by the isomerase enzyme. PGH2 can be reduced by the reductase enzyme to form PGF2 alpha, or PGH2 by the action of thromboxane synthase converted to thromboxane N2, or by the action of prostacyclin synthase it synthesizes the prostacyclin, this PGI2. Aspirin can inhibit the thromboxane synthase and prostacyclin synthase. Then when the arachidonic acid enters into the lipoxygenase pathway, first it synthesizes the 5-HPETE. Then after liberation of water, it forms the leukotrienes A4. Then when water is introduced into the leukotrienes A4, it forms the leukotrienes B4, or leukotrienes A4 by the action of glutathione S transferase is converted to leukotrienes C4 by introduction of glutathione. Then leukotrienes C4 after liberation of glutamic acid it can convert it to leukotrienes D4. Then leukotrienes D4 after liberation of glycine it can forms leukotrienes E4. So in this way different types of leukotrienes can be formed, and the leukotrienes C4, D4, E4 are called SRSA, that is compound, that is SRSA compound, that is the slow reacting substance A compound. Different drugs acts on the eicosanoids biosynthesis. For example, leukotrienes receptor antagonists are Zafilukast and Montelukast. Preferential COX-2 inhibitors are linvoseltamide, meloxicam, and nabibutal. Selective COX-2 inhibitors are celecoxib, rafecoxib, and valdecoxib. That's all for today. Thank you.